video is sponsored by Yaskawa. Hi, I'm Miles Budimir with Design World Magazine, and we're here with another installment in our Motion Control Basics series, and this time we're here to talk about servo motors. Now, basically, the hallmark of any servo motor is the presence of feedback and closed-loop control. Servo motors are able to provide precise control of torque, speed, or position using closed-loop feedback. They can also operate at zero speed while maintaining enough torque to maintain a load in a given position. Servo motors have several distinct advantages over other types of motors. For starters, they offer more precise control of motion. This means they can accommodate complex motion patterns and profiles more readily. Also, because the level of precision offered is high, the position error is greatly reduced. All servo motors have essentially three components: a motor, a feedback device, and some type of electronic control. The electric motor itself can be either an AC or a DC motor. Under the DC heading, brushed DC servo motors are generally less expensive than brushless servos, but do require more maintenance due to the brushes needed for the motor commutation. Brushless servo motors are more expensive than brushed DC motors. Generally, these are used in applications requiring higher torque. Brushless DC servo motors are highly reliable and virtually maintenance-free. However, the drives for brushless DC servo motors are more complex because the commutation is done electronically rather than mechanically, as in the brushed DC motor. Another way to classify servo motors can be as either single-phase or three-phase. Motors of the single-phase variety can range from simple and inexpensive brushed DC motors to voice coils for small micro and nano positioning applications. Servo motors also require a form of feedback, often with the feedback device, such as an encoder or resolver, built right into the motor frame. The feedback signal is needed by the control circuitry to close the control loop. Lastly, the control circuitry typically involves a motion controller, which generates the motion profile for the motor, and a motor drive, which supplies power to the motor based on the commands from the motion controller. Servo motors are used in many industrial applications, from machine tools, packaging machinery, communications, and robotics applications, to newer applications such as solar panel control and a broad range of automation control applications. The diversity of applications means that servo motors are designed for general-purpose indoor environments, but also for specialized situations requiring them to withstand extreme temperatures and pressures outdoors, as well as the special demands of food processing industries in washdown environments.